In the heart of the Antarctic winter, a vast unbroken shield of sea ice stretches for millions of square kilometers, forming a seemingly impenetrable barrier between the frigid air above and the dark, mysterious ocean below. This frozen expanse is so extensive that it covers an area larger than most continents, locking away the Southern Ocean in a grip of relentless cold. It is one of Earth's most formidable landscapes, a place where temperatures plunge far below freezing and the sun barely rises for months on end. Life here is rare and resilient, and the environment is as harsh as it is beautiful. Yet, in 2016 and 2017, satellites detected a baffling anomaly. An enormous patch of open ocean, hundreds of kilometers from the nearest ice edge, suddenly appeared and began to expand at an astonishing rate. This was a phenomenon that defied expectations and left scientists around the world searching for answers. This was no ordinary crack in the ice. It was a colossal polynya, a vast window of open water as large as Switzerland, appearing deep within the winter ice pack for the first time in over 40 years. The sheer scale of this opening was almost unimaginable, and it challenged everything scientists thought they knew about Antarctic sea ice. Scientists were stunned. What force could possibly melt so much ice and keep it from refreezing in such brutal cold, where temperatures can drop to minus 40 degrees Celsius? The existence of this polynya raised urgent questions about the hidden dynamics of the Southern Ocean and the powerful forces at play beneath the ice. The sea ice is a critical part of the global climate machine, reflecting sunlight back into space and insulating the ocean below from the freezing air. Its presence helps regulate Earth's temperature and influences weather patterns around the world. Its sudden breach signaled powerful, possibly changing processes at work beneath the surface. Currents, winds, and perhaps even changes in ocean heat rising from the depths. The appearance of the polynya hinted at a world in flux, where the balance between ice and ocean is more delicate than we ever imagined. Researchers worldwide raced to investigate, pooling satellite data, robotic floats, and advanced weather models to unravel the mystery. Teams collaborated across continents, deploying new technology and sharing insights in real time, determined to understand what had triggered this extraordinary event. The Maud Rise polynya became a scientific detective story, one with implications for ocean circulation, global climate, and the future of polar environments far beyond Antarctica. Every new discovery brought more questions, and the world watched as the story unfolded. This was a rare glimpse into the dynamic, hidden forces shaping our planet, a reminder that even in the most remote and frozen corners of the Earth, change can come suddenly, rewriting the rules of nature before our eyes. To truly grasp the significance of this phenomenon, we must first understand what a polynya is, an area of open water surrounded by a vast expanse of sea ice, often appearing as a mysterious dark patch in an otherwise frozen landscape. These rare openings in the ice are windows into the dynamic processes at work beneath the surface of the Antarctic. Most polynyas are formed by the relentless force of strong coastal winds, which push the sea ice away from the shore, exposing the water below to the frigid polar air. But the 2017 polynya was unlike anything seen in decades, a rare open ocean polynya located far from any landmass. This vast opening was not carved out by wind, but by an extraordinary surge of warmth rising from the ocean's depths, defying the usual rules of Antarctic ice formation. Under normal conditions, a stable layering exists. Cold, fresh water floats on top of denser, warmer, saltier water, effectively trapping the heat deep below the surface and keeping the ice above intact. The sudden appearance of a Switzerland-sized hole in the sea ice signaled that this delicate balance had been violently upended, allowing the hidden warmth to break through. Deep, warm water surged upward with unexpected force, melting the thick ice from below and preventing it from refreezing, even as temperatures plummeted above. The last time an event of this magnitude was observed was back in the 1970s. Its sudden return after so many years raised urgent questions among scientists and climate experts. Was this a random anomaly, or a warning sign of profound changes underway in the Southern Ocean? Thanks to advances in modern technology, researchers could now monitor and study the polynya in real time, deploying sophisticated instruments to collect data and unravel the mysteries of this dramatic event. Insights that are vital for understanding the future of Antarctica's sea ice and its crucial role in regulating Earth's climate. The Polynya became a natural laboratory, offering scientists a rare opportunity to observe, measure, and ultimately unravel the powerful forces that govern our oceans and shape the fate of our planet. The Polynya's location was no accident. Its appearance in the remote Weddell Sea was shaped by forces hidden far beneath the waves, where the ocean's secrets are written in stone and current. It formed above Maud Rise, a massive underwater mountain in the Weddell Sea, whose summit lies hundreds of meters below the surface, yet whose influence reaches all the way to the ice above. Rising an astonishing 4,600 meters from the seafloor, taller than many mountains on land, Maud Rise disrupts the powerful Weddell Gyre, forcing water to swirl around its summit in a persistent, churning vortex that never truly rests. This swirling vortex acts like a trap, capturing warm, salty, deep water and holding it close to the surface. Here, the stage is set for a dramatic process: convection, where the trapped heat rises and melts the sea ice from below, even in the heart of the Antarctic winter. Without Maud Rise, this precious heat would simply disperse into the vast southern ocean. Instead, the mountain creates a persistent hotspot of instability, a place where the ocean's energy is focused and amplified. For decades, scientists suspected Maud Rise was special, but its true power remained hidden. Only with the dramatic reappearance of the Polynya in 2017 could they finally connect the seafloor's hidden topography to the dramatic events unfolding at the surface. The mountain is not just a passive feature, it's an active player, triggering a chain reaction that tore open the Antarctic ice and revealed the dynamic forces at work beneath. The return of the Polynya allowed researchers to see, with new clarity, how geology and oceanography collide in this remote corner of the world, and how a single underwater mountain can shape the fate of an entire sea. Maud Rise set the stage for one of the most dramatic transformations in the Southern Ocean, reminding us that even the most hidden features of our planet can have world-changing effects. Maud Rise set the stage, but a trigger was needed. The Weddell Gyre, a vast clockwise ocean current, began spinning faster in the years before 2017. This intensification lifted the warm, salty deep water closer to the ice, thinning the insulating cold layer above. The ocean was being primed for upheaval, with heat lurking just below the surface. Why did the gyre strengthen? Shifts in wind patterns, possibly linked to global climate change, pumped more energy into the current. This shows how distant atmospheric changes can reshape the Antarctic landscape. The system grew unstable, ready for a disturbance that could unleash the deep ocean's heat. The stage was set for the Polynya's dramatic opening. With deep heat near the surface, another process took over: Ekman transport. Earth's rotation causes surface water, pushed by wind, to move at a right angle, in the southern hemisphere, to the left. As winds swept across the Weddell Sea, Ekman transport funneled increasingly salty surface water onto Maud Rise. This influx of salt increased the surface water's density, eventually making it heavier than the water below. The stable layering broke down. Heavy surface water began to sink, triggering deep convection. Cold, dense water plunged downward, forcing warm water up, switching on the Polynya's engine. This sequence, gyre-driven upwelling, then Ekman-driven salinity, shows how subtle forces can combine to unleash dramatic change. It wasn't brute force, but a delicate chain reaction. The Antarctic Sea, once stable, became a churning cauldron of deep ocean water. The Polynya's formation was a masterclass in planetary physics. Once convection began, two more forces ensured the Polynya's persistence: wild weather and turbulent eddies. In 2017, intense storms and atmospheric rivers battered Maud Rise, pushing sea ice away and exposing more ocean. This created a feedback loop. Open water released more heat, fueling further storms and keeping the Polynya open. The storms also enhanced Ekman transport, driving even more salty water onto Maud Rise. Meanwhile, swirling ocean eddies acted as pumps, mixing warm, salty water upward and preventing new ice from forming. The combination of deep convection, storms, and eddies made the 2017 Polynya exceptionally large and persistent. Once opened, the hole in the ice vented deep ocean heat into the Antarctic night for weeks. The Maud Rise Polynya was more than a local event, it was a global engine. The open water vented heat into the polar atmosphere at over 20 times the normal rate, releasing energy stored in the deep ocean. but it also released ancient carbon dioxide, stored for centuries, into the air. A critical climate feedback. Most importantly, the polynya drove deep convection, forming Antarctic bottom water that powers the global ocean conveyor belt. This process circulates heat, salt, and nutrients worldwide, regulating climate far beyond Antarctica. The 2017 polynya's impact will echo for years, subtly altering ocean currents and heat transport. It was a vivid reminder that the Southern Ocean is a key driver of Earth's climate. The polynya's biological impact was immediate and dramatic. In the Antarctic winter, sea ice locks away the ocean's riches, making survival tough for air-breathing animals. The sudden open water became a lifeline, an oasis for seals, whales, and penguins, offering access to food and air. Seabirds like Antarctic petrels flocked to the polynya, able to forage locally instead of migrating vast distances. Deep convection brought nutrients to the surface, triggering phytoplankton blooms and supporting a thriving food web. The polynya became a hotspot of life in a frozen desert. These features are both indicators of physical change and vital refuges for Antarctic wildlife. Understanding polynyas is essential for predicting the future of these unique ecosystems. The Maud-Rise polynya is both a scientific mystery and a warning. The same forces that created it, strengthening winds, upwelling warm water, and intense storms, are being amplified by climate change. Antarctic sea ice is now in rapid decline, and polynyas like this may become more common. More frequent openings could accelerate the release of heat and carbon, creating feedback loops that speed up global warming. The production of Antarctic bottom water could shift, with unpredictable effects on the ocean conveyor belt and global climate. The polynya is a symptom of a system under stress, a real-world experiment in planetary change. Its story is a stark reminder: Earth's systems are deeply connected, and changes in Antarctica will ripple across the globe. The impossible hole in the ice is ultimately a glimpse into our own future.